Chemical bonds, properties. Bonding types determine many of the properties. We will be looking at the ionic, covalent or molecular, and metallic. First is the ionic substances. Compounds that have ionic bond are known as ionic compounds. The elements that most readily form ions are those that belong to group 1, which are your alkali metals, group 2, which are the alkaline earth metal, group 16, which is the chalcogen or the oxygen group, and group 17, your halogen. Remember, group 1 and group 2 are metals, and they lose electrons to form cations. And group 16 and 17 are non-metal, and they gain electrons to form anions. When an ion is formed, the atomic radius will be changed. For example, when the ion becomes a cation, that means they lost electrons, the atomic radius actually decreases. Whereas when the atom becomes an anion, gain electrons, the atomic radius will actually increase. Let's take lithium for example. Lithium has 3 electrons, 2 in the first shell and 1 in the outer shell. When lithium becomes a cation and it loses its electrons, what actually happens is that lithium would actually become smaller. So what happened is, before, lithium would look like this, but afterward, when lithium loses this valence electron, it would look like this. And so the electron shell will actually be smaller because there will not be an outer shell. Ionic bonds always tend to produce giant ionic structures. The ions form a very closely packed regular lattice. There are very strong chemical bonds between other ions. A single crystal of salt, for example, is one giant ionic lattice, which is why salt crystals tend to be cuboid in shape. They tend to have high melting points and boiling point due to the very strong chemical bond between all the ions. They tend to dissolve to form solutions that conduct electricity. When dissolved, the ions separate and are free to move in the solution, so they will carry the electric current. They conduct electricity when molten, so that when the substance melts, the ions are free to move, so they will also carry electric current. The next group is the covalent substance. The size of the covalent substance tend to be simple molecules or giant structures. Covalent compounds tend to contain molecules with small number of atoms. The bond between the atoms are very strong covalent bonds. The force of attraction between the covalent molecules are very weak. The result of the weak or feeble intermolecular forces is that the melting and boiling point are low because the molecules are easily separated from each other. They are also known as molecular substances, so covalent substances are also known as molecular substances. Because of the weak intermolecular forces between the molecules, most molecular substances are gas or liquid at room temperature. Molecular substances do not conduct electricity simply because there are no ions. They do not dissolve in water usually, and the physical state is usually kind of mushy, liquid or gas, or an easily melted solid. If they do form giant structure, all the atoms are bonded to each other by strong covalent bond, and they tend to have high melting and boiling point. They do not conduct electricity, and they are usually insoluble in water. For example, SiO2 is a quartz. Okay, carbon form 2 giant covalent substances. For example, diamond and graphite. Our third type of substance is the metallic substances. The metallic substances tend to form giant structures of atoms. Metallic bonds involve the all-important free electrons, remember the free seed of electrons, which produce the characteristic property of metal, such as these free electrons come from the outer shell of the metal. These free electrons are free to move about, so metal conduct heat and electricity. These free electrons hold the atom together, And this free electron allows the atom to slide over each other, thereby causing the metal to be malleable or easily made into thin sheets. The metals tend to form alloys or mixing it with a non-metal element. This property can be different in the original individual atom and is normally useful in manufacturing engineering. For example, we do steel, which is a combination of iron and carbon, or solder, which is a combination of lead and tin, or brass, which is a combination of copper and zinc, or copper nickel, which is a combination of copper and nickel.